with the combustions packet. Got an hour-and-a-half block set up, so we'll see how it goes. First thing we're going to do is work on the combustion packet, which will be the end of chemical reactions, which we will take care of today. So, getting started with the combustion packet. Again, this packet is all combustion reactions. The first one in the packet is CH4. All combustion reactions have the same format. You're going to have the hydrocarbon, you're going to add oxygen, carbon dioxide, and water. So I find it, as I've done in the videos, if you've watched any of those, I set up a grid, team reacts, team prods, and I start with carbon. I've got one there, one there. Don't need to adjust the carbon. So then I go on to team hydrogen. I've got 4 here. So my need here is 4. So 2 goes into 4 2 times, and I have 4 hydrogens. And I'm done with hydrogen. The trick with combustion is the oxygen atom. That one, so I like to call it the money shot. So you got 2 oxygens here, 2 times 1 here, you got 2. 2 plus 2 makes 4. So your need here is 4. Now sometimes you got to check what I call the hole card here and see if there's any oxygens in the hole, and there's not. So you've just got to place a coefficient there to get 4. 2 goes into 4, 2 times 2 times 2 gets you 4. And that's how you knock out combustion reactions. That's the most simple, the most basic combustion reaction you can have. CH4. And on to, it looks like C2H6. Notice that the format of the reaction is always the same. You've got oxygen, carbon dioxide, and water. It does not matter if you put the water here and the CO2 there. It's still going to get balanced the same. So you set up a grid, team reacts, team prods. You've got carbon. You've got 2, so you're going to need here, your need here is 2. So you're going to put a 2 in there, and carbon's done. And you're on to hydrogen. So you've got 6 here, so your need here is 6. 2 goes into 6 3 times, or 3 times 2 is 6. That's done. So next is oxygen. So going to take oxygen, count them up. 2 times 2 is 4, 3 times 1 is 3, 4 plus 3 equals 7. So 7 is what you need here. Okay. Problem is 7 is odd. So when that number is odd, you have nothing in the hole here to worry about. You take that odd number and you place it over 2. Then you go through and you're going to multiply every coefficient by 2 to get rid of that fraction. So you're going to double here, the 2 goes away, you double the 2 to make a 4, and you double the 3 to make a 6. And that's how you balance an odd combustion number there. Oh, let's see, the next one, C2H4. Again, you're going to start with carbon. You're going to go with 2. The need here is 2. Okay. Then you're going to go to hydrogen. You have 4 here. So the need here is 4. 2 goes into 4 2 times. Then you count your O's. 2 times 2, 4 there. 2 times 2, 2 times 1 here is 2. 4 plus 2 is 6. So your need here is 6. nothing in the hole, 2 goes into 6 3 times, and 3 times 2 gets you 6, and that one's done. All right, let's see here. C3H8. Again, start with carbon. You've got 3. The need here is 3. Then you're on to hydrogen. You have 8. The need here is 8. 2 goes into 8 4 times, or 4 times 2 gets you 8. So do the O count. 3 times 2 is 6. 4 times 1 is 4. When they're even, it's easy. 10. So your need here is 10. There's nothing in the hole. 2 goes into 10 5 times, and that's how you balance that. Let's see here. C3H6 is next. So it's off. Carbon first, you got 3, so your need there is 3. You have 6 hydrogens, the need here is 6. So 2 goes into 6 3 times. Then you do the O count. 3 times 2 is 6. 3 times 1 is 3. 6 and 3 is 9. Your need here is 9. It is odd. So you're going to take that 9, place it over the 2. And then you're going to go through and double down on everything. 2 cancels. 3 becomes 6. And 3 becomes a 6. All right, let's see that one's going on. Let's go to C6H6. Carbon is 6. Hydrogen is 6, so the need here is 6. 2 goes into 6 3 times. Going to do our O count. 6 times 2 is 12. 3 times 1 is 3. 12 and 3 is 15. 15 is indeed odd. Nothing in the hole to subtract out, so you're going to take that 15, place it over 2, and then you're going to go through and double down on everything. 2, that cancels, the 6 becomes 12, and the 3 becomes 6. Let's see, we've got a C8H18. So let's see here. We got 8, 18. So your need here is 18. 2 goes into 18 9 times. Now we got some arithmetic to do. 16. 8 times 2 is 16 for the O. 9 times 1 is 9. And we've got what there? 25. Yep, 25. I'll check my math. 25 is odd. Have nothing in the hole to subtract out, so I got to go with a 25 over 2. I got to go back and double down on everything. 2, becomes 16. 9 times 2 becomes 18. And that's how you knock that one out. Let's see that one. Next up is C8, H16. Let's take a look at this. We got 8 for carbon, 16, so your need here is 16, 2 goes into 16 8 times. That's the easy part. It's always oxygen that is where the money gets made. So you're going to take 8 times 2 is 16, and 8 times 1 is 8, so we are going to have 24 there. 24 is even. That's our need. We have nothing in the hole to subtract out. 2 goes into 24 12 times, and that one's done. Okay, next up, C9H18. Let's go here with 9, 18. Our need here is 18. 2 goes into 18 9 times, so that takes care of carbon and hydrogen. Then we do the oxygen count. 9 times 2 is 18, and 9 and 1, 9. So we've got what there, 27. And let's see, 27 is odd, so we take 27 over 2, and then we get rid of that fraction. So cancels, 9 becomes 18, and the 9 becomes 18. There you have it. Got C6H12. Now in this case, we got oxygen in the hole, so we deal with that one last. So you always take it in order. You got carbon, 6. So you know you're gonna need a 6 there. You got 12. And your need here is 12. 2 goes into 12 6 times. Good on that. Then we get busy on oxygen. Got 6 times 2 is 12. 6 times 1 is 6. So the need here is 18. The problem is you've got 6 in the hole, so you have to take that 18 that you need, subtract whatever's in the hole here, and in the hole you have 6. So that becomes 12 is what your net need is. So your need's not 18, but your need is 12. 2 goes into 12 6 times. That's that one. Next one. So C3, H6O plus O2, 2CO2, H2O. So we've got carbon, we've got 3, hydrogen, we got 6. So our need here is 6. 2 goes into 6 3 times. And then we do the O count. 3 times 2 is 6. 3 times 1 is 3. 6 and 3 is 9, so my net need here is 9, but I have 1 in the hole, so my whole oxygen is 1. So 9 minus 1 is 8, so my net need is not 9, but it is 8. 2 goes into 8 4 times, and that one's done. Next up, we got C4 H8O2. So let's do carbon. Carbon's 4, so your need here is 4. Hydrogen 8. The need here is 8. 2 goes into 8 4 times. Then you do the O count. 4 times 2 is 8. 4 times 1 is 4. 8 and 4 is 12. So your need here is 12, but you have 2 in the hole. So you take that 12 minus your 2 from the hole, and your net need is 10. So 2 goes into 10 5 times. Page 1. Any questions on that first page? Going on to the second page of the combustion packet. Let's take a look. We've done CH4, that first one, so I'm going to jump right on down to the second one where we have CH3OH plus O2 makes CO2 plus H2O. Well, the twist here is you got to remember you got to add the total number of hydrogens up. So when you do hydrogen, some forget to add that H there. It's kind of sneaking out at the end. Carbons 1 and 1, that's done. Hydrogen, you got to remember you got to add the total hydrogens here. 3 plus 1. So we have 4 there, so your need here is 4. 2 goes into 4 2 times. So do the O count. Let's see here, we got the O count. We got 2 O's here. 2 times 1 is 2. That's 4 is our need. But we have 1 as a whole. So we got 1, so we got 3. And 3 is odd. So we treat that the same as we would any odd situation. Take that 3 over 2. And then we're going to double down on everything. So that's going to become a 2, that becomes a 3, that becomes a 2, and that becomes a 4. Okay, let's see. C2, number 3, C2H6 plus O2, CO2 plus H2O. 2 carbons, 6 hydrogens, then do the O count. We've got 2 times 2 is 4, 3 times 1 is 3, is 7, which is odd. You have nothing in the hole, so you go ahead and put the 7 over 2. And then you double down. 2 cancels, 2 becomes 4, and 3 becomes 6. C2H2. Look at that. We've got 2 carbons, 2 hydrogens. We're good. Then we just jump to the O count. So we got 2 times 2 is 4, plus 1 is 5. 5 is odd. There's nothing in the hole. 5 over 2. And then we go ahead and double down on everything. 2, 5, 4, and 2. Number 5, C3H8 plus O2, CO2, H2O. This gets very robotic after a while because your plan of attack is always the same. Carbon 3, hydrogen 8, so your need is an 8, 2 goes into 8 4 times. Then you go ahead and get busy on the O's. 3 times 2 is 6, 4 times 1 is 4, 6 and 4 is 10. 10 is even, nothing in the hole, 2 goes into 10, 5. It's always an easy knockout when this is even. We got C2, H5OH. Let's go ahead. Carbon is 2. Hydrogen, you got to remember, you got to add both of these. 5 plus 1 is 6. So your need there is 6. 2 goes into 6 3 times. You do your O count. 2 times 2 is 4. 3 times 1 is 3. 4 and 3 is 7. 7 is indeed odd. So you got 7 over 2. 2, 4, and 6. Let's see number 7, C2H4. Carbon is 2, hydrogen is 4. 2 times 2 gets us 4. Then we do the O count. 2 times 2 is 4. 2 times 1 is 2. 4 and 2 is 6. So our need here is 6. 2 goes into 6 3 times. That'll give us that one, which is number 7. Eight, C3H6. See, carbon is 3, hydrogen is 6, so I need a 3 there. 3 times 2 gets me my 6. Go ahead and do my O count. 3 times 2 is 6. 3 times 1 is 3. 6 and 3 is 9. 9 is odd. I have nothing in the holes to subtract out, so it's 9 over 2. And then I need to double down on everything. 2, 9, 6, and 6. C6H6, O2, CO2, and H2O. So we go ahead and we have 6 for carbon, 6 for hydrogen, so put a 3 there. We'll go 6 times 2 is 12, 3 times 1 is 3, 15, 15 is odd. We'll take the odd number since we have nothing in the hole here, place that over 2, and then we're going to go ahead and double everything down. 2 cancels, 6 becomes 12, and the 3 becomes 6. Number 10, C4H10 plus O2 makes CO2 and O. Carbon is 4, hydrogen is 10, so you need a 5. Okay? 5 times 2 gets you that needed 10. You do the O count, 4 times 2 is 8, 5 times 1 is 5, so we have 13 there, 13. Odd, nothing in the hole to subtract out, so you go 13 over 2, and then you double down on everything. 2 cancels, 4 becomes an 8, and the 5 becomes a 10. All right, number 11. C8, H18. For some reason, they went ahead and gave us the 25O2. Let's balance it out. Let's see, we got 8 for carbon. We got 18 here, so we're going to need 9 for hydrogen. So do our O count. 8 times 2 is 16. 9 times 1 is 9. 9 and 6 would be indeed 25. The problem is this is not done because 25 times 2 is 50 O's. 50 does not equal 25. So what we have to do is that 25 should be over 2, and then we go ahead and double everything down. The 8 becomes a 16, and the 9 becomes an 18. That one is indeed now made correct. Number 12. C6, H12, 6 plus O2 to CO2. I can even write that 6 in there. I'm sure that's correct, and it is because you put the 6 there from carbon. 12 is hydrogen, so you're going to need another 6. And then we're going to go ahead and do our O count. 6 times 2 is 12. 6 times 1 is 6. That's 18. So our need here is 18, but we have 6 in the hole. So we got the whole number here is 6. So we have to subtract that 6, and we're going to end up with a net total need. I like to call it the net need. It's 12, so it's not 18. It is 12. 2 goes into 12 6 times. C7, H16 plus O2, CO2, and O. C7 for carbon, 16 for hydrogen, which would be 8. 8 times 2 gives me my need is 16. Then I do my O count. 7 times 2, 14. 8. That's going to be 22. which is indeed even. Have nothing in the hole. 2 goes into 22 11 times. Number 14, C5, H12, O2, CO2, and O. You've got 5 for carbon, 12 for hydrogen. 6 times 2 gives me 12. I do my O count. 5 times 2 is 10. 6 times 1 is 6. 16 is my need. 16 is indeed even. 2 goes into 16 8 times. And there you have it. Number 15 looks a little different. Got C6H4 OH2 plus O2 to CO2 plus H2O. So our total carbon, I'm going to always start with that, is 6. And for my hydrogens, I've got 2 here plus that 4. So my total hydrogen count is 6. 6 for H, so my need here is 6. 2 goes into 6 3 times. Then I'm going to do my 6 times 2 is 12. 3 times 1 is 3. 12 and 3 is 15. 15 is indeed odd, but I've got some hole to play here. I've got 2 oxygens in the hole, so 15 is what I need, but I have 2 in the hole. So 15 minus 2 is 13. That is my net. So my net is 13, which is still odd. So we've got 13 over 2, and then I double everything down. 2, that cancels. The 6 becomes a 12, and the 3 becomes 6. And that is page 2 of the combustion packet. So we'll keep rolling. So we got number 16 next, which is C4H8. So our net here is 4. Our net here is 18, so we need 9. 9 times 2 gives me my 18. And I go back and check my hydrogen count. I've got 8 here and 9 here, so I've got what? 17. 17 is indeed odd. So I'm just going to take, there's nothing in the hole, so I'm going to take that 17 over 2, and then I'm going to go ahead and double down on everything. 2, 17, 8, and 18. C3H6, O2, CO2, H2O. Carbon, we've got 3, hydrogen 6. So my need here is 6. 3 times 2 gives me about 6. And I'm going to do my O count. 3 times 2 is 6. 3 times 1 is 3. 6 and 3 is 9. 9 is odd. Have nothing in the hole to subtract out. 9 over 2, 2, 9, 6, and 6. 18, C6H12 plus O2, CO2, and H2O. Let's see, carbon first, 6, hydrogen 12, need here is 12, 6 times 2 gets you 12. And you've got O count, 6 times 2 is 12, 6 times 1 is 6, 6 and 12 is 18. 18 is our need. It is indeed even. 2 goes into 18 9 times, and that one's done. $19, C4, H8 plus O2 to CO2 and H2O. Same attack, 4 carbons, 8 hydrogens, 4 times 2 is 8. So we go ahead and do our O count. 4 times 2 is 8. 4 times 1 is 4. 8, 4 is 12. 12 is even. Nothing in the hole. 2 goes into 12 6 times, and we're done. Let's see, number 20, C9H14 plus O2 to CO2 and H2O. So we got here, we got 9, 14, which means we need 7. 7 times 2 is 14. We got 9 and 2 is going to be 18. 7, that's going to be 20 plus 5 will be 25. 25 is going to be odd, nothing in the hole. Take 25 over 2, and then we go ahead and finish. 2, 25, 9, 18, 7 is 14, and we are done. C1, C4, H8, H2, plus O2 to CO2 plus H2O. All right, 4 carbons here. I gotta watch for my hydrogens because I got 2 here hiding. So 8 plus 2 is 10. So my need here is 5, which gives me 10. And then I go after my O's. 4 times 2 is 8. 5 times 1 is 5. So I get 13 there. Didn't even write it up there because I know I have 2 in my hole. 1 times 2 is 2. I have 2 from the hole. So that becomes 11. So 11 is my need, but it is odd. So I'm going to have to do this, 11 over 2, and then double down on everything. 4 becomes an 8, and 5 becomes a 10. Oh, by the way, I don't think they're going to cut us off today. The campus upgraded to the deluxe package, so I don't think we're going to have to stop and load the other link. They'll just let us continue for the regular class time. Number 22, C5H6, O2, CO2, and H2O. 5 on carbon, 6 on hydrogen, and 3 times 2 gives us a 6. So we've got 10 oxygens, 3 times 1 is 3. That's 13. So 13 is odd. 13 over 2. So let's see here. We got to double down on everything. 2, cross that out. 10 and 6. We got C25, H52 plus O2 to CO2 plus H2O. So we're going to have 25. Half of 52 is going to be 26. So we're going to have 26 times 2 to give me my 52 there. And then I'm going to have a whole bunch of O's. 25 times 2 is 50. 26 times 1 is 26. So I'm going to have 76, which is even. And I've got what? 35, 36, 38. And 38 times 2 should give me my 76. That math in my head this morning. So that is for 23. Four, 17, 26, 2, 2, 17 on carbon, 26 would be 13 on hydrogen, 13 times 2 gives me about 26. So I do my O count, I've got 34 here, 13 times 1 is 13, so I'm going to have 47, which is odd. So go ahead and my odd number and then double down. 2, 17 and 17 would be 34, and this would be 26. Looks interesting. C12, H21, OH5 plus O2, CO2 plus H2. Again, you've got some hydrogen in the hole here, so the total hydrogen, you got to add that up. It's 21 plus 5 is 26. Okay. That was odd, then we got to do a whole different step to it. 26 is even, so I can go ahead. Well, I'm jumping ahead of myself. Carbon is 12, so I need to put that 12 there. Now I got 26, I can go ahead and put that 13 there. And let's go ahead and knock out the oxygen. 12 times 2 is 14, 13 times 1 is 13. So I'm going to have 27 that I need. So my need here is 27, but I've got a bunch of hole to play here. Got 1 times 5 is 5, so I have 5 in the hole. So I have to subtract out my whole oxygen. So it's going to be 22, which will be even. So I take that 22 up here. Even 2 goes into 22 11 times, and there's nothing to adjust. That's 25. Six. C3H7 OH plus O2 to CO2 plus H2. Let's see, I'm going to go 3 here. And I've got 7 plus 1 is 8, so I'm going to need a 4 there. Don't forget to add that trailer there, because you can't balance an odd and an even. You have to double down here to start. That's the twist with an odd number of hydrogens. 3 times 2 is 6, 4 times 1 is 4, 6 and 4 is 10, 10 is even, 2 goes into 10 5 times. And that one is done. 6. 7, we've got C6H12O6 plus O2 to CO2 plus H2O. So we've got 6 for carbon, 12 for hydrogens. We need another 6. We've done this one twice before. 6 times 2 is 12. 6 times 1 is 6. The total here is 18. 18 is our need, but we have 6 in the hole. So that's going to be 12. So 12 is our net. 2 goes into 12 6 times. And that takes care of 27. H 12, H22, O11. Looks like we got sugar here. O2, CO2, and H2O. Let's see here, 12. Start with what we know, 22, 11, then we do our O count. So we got 12 times 2 is 24, 11 times 1 is 11. So we've got, what, 35 there is our net need. But we have 11 in the hole, so there's our whole number there. 5 minus 1 is 4, 3 minus 1 is 2. So our net is 24 is what we need. 2 goes into 24 12 times. It's done. CO2 and H2. Okay, let's get busy here. Carbon 7. Okay, hydrogen, we got some arithmetic to do. We got 7 here, 7 there, 7 plus 7 is 14. And then we got some whole oxygens there to worry about too. So, 7 times 2 is 14, 7 times 1 is 7, 14 and 7 is 21. See, 21 is what we need, but we have 7 in the hole. So 14 is net. 2 goes into 14 7 times, and that one's done. That's 29. We've got C10. H8, SO2, so let's see here. We've got 10, we've got 8 is 4, do our O count. 10 times 2 is 20, 4 times 1 is 4, 24. Even, nothing in the hole, 2 goes into 24 12 times. That's the number. And I used that red pen. That was brilliant. Get busy on this red stuff. Right. Is there any questions on the combustion packet? If not, I'm going to go ahead and move on to nukes. Because all there is there's another page, but they look straightforward. To do that stuff in here, again, that's all in the key, and so is this stuff. This is all on the combustion packet key, because I did really want to move on to nukes. So moving on to nukes, I sent you the nuclear instructions packet out. I'm just getting it to load right here. It's just a brief set of instructions on doing nuclear reactions. In a nuclear reaction, you have to remember way back when we did something like this. We looked at isotopes. A nuclear reaction involved what's called isotopes. Isotopes, you had the top number, which is your mass. Here, your mass is protons plus neutrons, and your bottom number, which was your atomic number, okay, or the number of protons. And I sent you the file on the instructions so you can follow along in what I'm doing here. To make this make sense, nuclear reactions are completely shifting gears. Because a nuclear reaction, what has to equal are the numbers. There's no atoms to balance. In the last packet, we looked at single reactions, double reactions, what else? Combustion, decomp, and synthesis. In here, they follow a strict format. You have the atomic numbers on the bottom, and they must add up on both sides. So if you have 95 here, 95 must equal 93 plus 2, which it does. 95 equals 95. And this top one here, 241, is 237 plus 4 is equal to 241. That's the game you play when you do nuclear reactions. The first up I'm going to look at is in that packet is what's called an alpha emission. You have that a lot long, you can scroll along. The first one up was an isotope of radium, and it was 88, and it underwent what's called an alpha. And an alpha particle is equal to a helium atom. That's what an alpha particle is. So this emits an alpha particle, and then what you need to do in any nuclear reaction is you're going to fill in the missing piece, or I like to call it the missing part. Okay? Think of it as a puzzle. Okay? You've got this part plus this part, and you need to fill in the last part. So to do this, you take 226 here, and you subtract out what you've got, 266, that was good. Okay. 226 minus 4 is going to be 222. So you write that as the top number, 222, because 222 plus 4 equals 226. Okay. You do the same thing on the bottom number. On the bottom number, you're going to take 88, and you're going to subtract that 2 out, which would be 86. 86 plus 2 is 88. Then you find yourself a periodic table. And in box number 86, you find radon. And you fill in the missing symbol. So we just balanced our first nuclear reaction. Next up, I've got on that instructions packet, I have U-238. Undergoing an alpha emission. Again, that's an alpha particle. And then we need to fill in the missing part. And that missing part, by the way, is what's called a daughter isotope in nuclear jargon. So we take 238 and we subtract 4 from that. 238 minus 4 is 234, or 234 plus 4 gets you to 238. 92 minus 2 is 90, or 90 plus 2 is 92. Okay. And in box 90, we find thorium. Okay. When you're working in the Nukes packet, which is what we'll do the rest of this week, is you want to make sure you have a periodic table handy, because to balance the nukes, you do need a periodic table handy. Okay. So in box 90, I said I had thorium, so I put in the symbol, and wham, done. Okay. So let's keep going on here. Work our way through the instructional packet. Let's see what we got next. We got radon 222. And we got 86. Okay. Again, emits an alpha particle. Okay. So what we do here is we subtract the numbers out. We got 220, which would be 218. So that stupid red one again. Put that thing away. We've got 86 minus 2 is 84. In box 84, I believe you will find polonium. Yes, I'm right. Okay. And this is how this game's played. Nukes are pretty easy. There'll be a couple of them in the sheet or the packets. on one specific sheet where you have to balance it using neutrons, and that one gets a little tricky. Most of these are pretty straightforward. So next up, we've got plutonium-244. That is 94, 42He, plus, again, the missing piece. And the missing piece is what we want to fill in. Again, 244 minus 4, 240. 94 minus 2 is 92. Box 92 is uranium. Next up would be a beta emission. And a beta emission, I'm going to start with U-239 on the packet. This is a beta particle, also called an electron. So, top number does not change. 239 minus 0 is still 239. Now, here you got a -1. You can't go 92 minus 1 and put a 91 there. That math does not add up because a 91 and a -1 is 90. 90 does not equal 92. You need to step the game up. It's 92 plus 1, which is 93, because 93 minus -1 is 92. And in box 93, we have neptunium. Next one up in that packet is U-238. Undergoes a beta and then the missing piece. So the missing piece, again, slide the 238 over, got 92 and -1, so we want a 93 there, and 93 again is going to be neptunium. Let's see, and we've got one more example here of a beta decay. Got 237, 93, neptunium, it's blank. So, slide the 237 over, kick up from 93, you kick up to 94. 94, I believe, is plutonium. Yes. And that's how you knock that one out. Okay, next one up in the list is going to be 249, 96. Curium, 0, -1E plus blank. 249 slides over. 96 plus 1 is 97. 97 and -1 is 96. And in box 96, we have curium. And let's see, what do we got next? Oh, gamma. And we're on done with beta. And then we're on to and the example I have is a 12-6 going to a 12-6 plus a gamma. With a gamma, there's no mass change and there's no atomic number change. Gamma is just energy. What you have here is this carbon is what's called an excited state, which means it's been zapped with some type of energy to get it into a high state. And what happens is this is the energy release. But there's no net change. Again, your atomic numbers are the same, and your mass number is the same. That's gamma. Let's see. Then last in that instructional packet was decay change, and we start with 238.92, and it undergoes a beta decay. So 238 minus 4 is going to be 234, and 90, which is, I want to say thorium. Yep, I was right. Okay. And in a decay series, what happens is you take the product from the first process, that gets used in the next step. So this is step 1 of a decay process. And in the next step, we take that 234.90 thorium, and that undergoes a decay process. And that undergoes a beta emission. So we take that, put the 234 there. And we got 91 here, and 91, we're going to have protactinium. And then we take this one, the 234.91 protactinium, and that's going to undergo a alpha emission. And that's going to make a new daughter isotope, which is going to be 230 and going to be 89. And 89 is going to be actinium. What's going on here is these isotopes are high energy. High energy isotopes are not stable. They're going to emit particles to reach an eventual stable isotope or a very low energy isotope, and that's how they get rid of their energy and become more stable. So it's what's called a decay process. And that is the packet, instructional packet. It was titled Nuclear Reactions Instructions. And next, which we'll be spending the rest of the week on, is, I call it the Nukes packet. And in the Nukes packet, this is going to be what the Nukes packet looks like. The first page is going to be titled P10 Exercises Nuclear Equations. So we're going to start right there. There is 11 of them. So let's get started. Number 1, we have 236.93 Neptunium. And notice they left the blank, and that's what we got to fill in. 236.94 plutonium. So what we have there is 236 and 236, so there's 0 mass change. We went from 93 to 94, but we got to get back to 93. So we put a -1 in there, which is a beta, and a beta fits in there perfect. 94 minus 1 is 93. And that's the first one on that sheet. So let's go to page 1. And number 2, let's see, we got 210.83 bismuth. starting to lean here a bit. 2, 42HE plus blank. Okay. So let's take a look at this. Let's see what we got here. So we go 210 minus 4, 206, 83 minus 2, 81, and 81. I think it's thallium. I'll double check that. Yes, I was right. Thallium. All right, on to number 3. Now, when you have like a number 3, you have multiple isotopes here, you have to add. 14 plus 4 is 18, 7 and 2 is 9. So you have a target to make here of what I like to call 18, I made that bar too high, 18 over 9. So 18 minus 1, which means I have to put 17 in here, and 9 minus 1 is an 8, so I put an 8 there, and then I just go to my periodic table, and in box 8 I find oxygen, and I put the symbol O in there, and that one's done. Number 4, 6C plus 10N, 2, got a coefficient here, 2, 10, and plus blank. This, by the way, you're going to run into this one a lot. This is a neutron. A neutron has mass of 1, but 0 atomic number. Remember, the neutrons were the green magnets when way back when we did the magnet board, like 6, 7 weeks ago. So nothing changes. We have to add 12 plus 1 is 13. So we're going to need 13 on top and 6 on the bottom. Okay. Now, but when we do this, you have to go coefficient times superscript, coefficient times subscript to get what you need. So 2 minus 1 is 2, so we're going to be taking 13 minus 2. 2 minus 0 is 0. So 6 minus 0 is 6 for the bottom number. 13 minus 2 is going to be 11 for the top number. And in box 11, we should have sodium. I'm sorry, box number 6. I'm looking at the, oh geez, been, yeah, too many numbers. Bottom number, that's the element. Oh my gosh. All right, that was good. That was brilliant. It's like there's no way that's the mass of sodium. Come on, dude. Really? All right, let's see. That's number 4. Number 5, we've got 21082. Lead to 21083 bismuth plus 1. So let's see, 210 minus 210 is 0. 0 here on top.
Call from William Wilson.
I got 83 minus 2 is 1.
Call from
So it looks like I'm going to need 0, negative 1E here. 83 minus 1 is 82, 210, 210. And this is going to be a beta. Okay. Number 11, 10N, 2, 3, 1, 3, 0n plus, I just did this in order going down the column, 9236 krypton plus blank. Oh no, we have a barium there. Okay, so 141.56 barium. Okay, so we need to fill in the blank. First thing we got to do is total everything up on this side. So we've got 3 times 1 is 3 here, got 92 here, and we've got 141 here. So we've got 92 and 92 and 3 is going to be 95, so that's going to be 6. So that's going to be 9, 10, 11, 12, 13, 1. That's going to be 236 on top. So I've got the top knocked out. And I'm going to do the bottom. 3 times 0 is 0. I've got 36 here, and that is indeed a 56. Yes, it is. So I got 56 and 36. I've got 12, 5, 6, 7, 8, 9, 92. So on this side, I have 236 to place and 92 to place. Doesn't matter how many isotopes you have, you're going to add the tops, you're going to add the bottoms. Okay? 236 minus 1, you're going to have 235 here, 92 and 0, 92, and a box 92, you have uranium. Okay. We're going to do one more, and then I'll take it open for questions. That was 11. Next on that list was number 6. Just going down that first column. 5326 Fe 20 plus 1E. This is a new particle here. We haven't seen that one before. Plus blank plus 0, 0 gamma. Okay. So let's see here. This, by the way, is what's called a positron, which is called antimatter. It's the opposite of an electron. It's an electron with a positive charge. Okay. So let's see, looks like 53 is going to slide straight across. And here we've got 26. So we have to take 26 minus this 1 and get 25. 25 plus 1 is 26. And in box 25, we have manganese. I knew that wasn't iron. That's it. And that's where I'm going to park the bus for this session. Probably do the other ones on a YouTube video for today. Is there any questions? We're into nukes now, so the end of Unit 3 is on the horizon, which means I'm probably going to email the test out next week. Is there any questions? Any questions? Any questions? Yeah, this is working much better without having to send out the links. So the campus has got us on the 90-minute program, so we're good. If there's no questions, I'm going to go ahead and end the meeting and leave you to your the rest of your day, and tell you to stay healthy. No questions? Question?
No.
I heard something. I heard. Did I hear something? Nope. Okay. Well, if there's no objections, I'm going to end the meeting unless there's somebody wants to chime in with some questions. Anybody at all? Anybody? Anybody? Okay, so we'll pick this up on Thursday. I'll be shooting some YouTube stuff out. That's still going up. The last YouTube I put out was the last page of the reactions packet, which was page 18. And there was 26 of them, and that was done in 5 parts. Those are all up on YouTube as of yesterday. I'm probably going to go ahead and do today on YouTube. I'm going to go ahead and put 7, 8, 9, and 10 from page 1 on YouTube. And then probably maybe on page 2, the first 6 on page 2. Any questions? Any questions? Any questions? Questions going once. Questions going twice. Questions going 3 times. So I'm going to end it, and I will see you all Thursday. So take care and stay healthy.